Hello, this is Lloyd from the Airgun Lab. Today we're going to try some impact testing, the outdoor facility here at my garden. What we're going to try and do, this is a simulated bolt and handle here. 1/2 inch diameter steel, quarter 28 bolt, simulate a handle. This ring simulates a breech. What we're going to do, okay, this simulates the bolt back and cocked, ready to fire. It is backwards. This would normally be the breech end of it. So it'll receive pressure from this side. Now what we're going to do is pretend like you hadn't locked the bolt, hadn't brought it back all the way, and you fired the gun, and the force, the air pressure, forced that bolt back and tried to shear the handle off. We're going to see what's going to happen. To do that, I've got a log and I've got a tamping bar up here. Tamping bar weighs 16 pounds. I'm going to try and get about 32 foot-pounds of energy out of this tamping bar, which means I'll raise this tamping bar up 2 feet, and then I'll drop it onto that bolt and see what happens. See what kind of damage it sustains. That 32 foot-pounds is maximum energy if you were shooting with 4,500 psi of air, shooting .458 caliber, and that bolt was allowed to fire backwards and try and break out of the back end of the breech. Kind of a scary situation. Well, we're going to take a look at it. Okay, I'm going to go ahead and get things set up, and I'll be back in a minute. All right, we're going to take a practice shot here. What I have is a piece of soapstone, fairly soft material. It's an inch thick. That's the end of the tamping bar, which weighs 16 pounds. We're going to raise this tamping bar up. There's a mark here on the corner of the pipe. That's at about 28 inches, 27 inches from the piece of soapstone. Energy that this is going to hit with, 16 pounds. It's real simple. 16 pounds times 2 1/4 feet, 36 foot-pounds of energy. All right, I'm going to raise this up, drop it, and we'll see what it does to the soapstone. By the way, I've been outside all day. It's hot and buggy, so that's why I look this way. Plus I'm old and tired, so I can't help it. Okay, here goes. Alright, so all it really did was just put a big crack in it. But pretty stuff. So, that's what it did to the soapstone. Now I'm going to go ahead and set up for this is the simulated bolt here with the handle, piece of aluminum that it's going to slide through. These are just spacers here. There's enough gap underneath here so that it'll have about a 1/4 inch of travel. Got it set up. Now, when I raise it up to that same mark, it's 24 inches, 16 pounds times 2 feet, It's going to give us 32 foot-pounds. I'm going to try and catch it on the rebound, see what happens. I'm going to take a look through the viewfinder again. Up at 2 feet. Here we go. All right. Well, that doesn't look too pretty. Let's take a look. Zoom in there. Okay, so it's kind of stuck in the aluminum here. It's bent up at an angle a little bit, but it's not sheared off. I'm going to tap it loose. Alright, so again, I'll put this back together. It doesn't look too good. The handle is bent, but it's not sheared off. It is embedded in the aluminum. Let me go ahead and get it out of the aluminum. It's kind of wedged in there. Pin punch and a hammer. I closed up the aluminum. I see what happened here. There we go. You can see where the handle bent and embedded into the aluminum. 6061 aluminum, like an aluminum breech, unless they're made out of 7075 or 2024, which is a little stronger. So, and it kind of distorted things a little bit. So that's why it's stuck. But anyway, it is not sheared off. It is bent. And we'll try and unscrew it and see what it looks like. Now, I'm going to take the bolt handle out of the bent bolt handle out of the bolt. .28 thread. Keep in mind, this is .28, and a lot of bolt handles, you know, are like 1032, 832, a heck of a lot smaller. It's a 3-line bolt here. It's at a grade 5, I think. So it's not a super sturdy bolt, but it's bent pretty. There's a mark in the aluminum. You can see how the handle is bent, but not broken. Could be a whole lot worse. And we're going to try something a little different this time. I've got just a standard .20 carriage bolt with a single nut on it. We're going to try and punch this carriage bolt through that nut using the same 32 foot-pounds that we used for the bolt handle. We're going to see what happens. It's only got about 3 threads in this nut, you know, but that's what, so it fits into a hole here in this block. And we're going to drop that down again from 2 feet, 32 foot-pounds. And we will see what happens. Here it goes. It actually appears to be fully intact, but I am not sure. I'm going to see if it'll unthread by hand. Thread it on by hand. If it unthreads by hand, that means that threads aren't too damaged. Well, actually it is pretty damaged. Looks like it slid up on this bolt, probably at least a 1/16 of an inch, maybe more. You see this shiny spot right there, that shiny section? That's where the nut slid up on the threads, absorbed all the energy as that happened, and deaccelerated the tamping bar. So all the energy went into stripping those threads up. Same thing with the bolt handle, you know. When that bolt handle bent, all of the energy went into, has to go somewhere, conservation of energy, into bending that metal and deforming the aluminum ring. So once all the energy was absorbed, you know, things stopped moving without any catastrophic failure, I guess you could say. Nobody was hurt here. I wasn't hurt, so that's it.